determine whether the following systems represented by impulse response are memoryless, causal and stable. So here impulse response of the system is given. We are supposed to verify whether the system is memoryless, causal or stable. Before proceed, let's see what are the conditions for the system to be memoryless, causal and stability. A system is said to be memoryless if h of n is equal to 0 for n is not equal to 0. This is the condition for memoryless system. Similarly, causal system, h of n must be 0 for n less than 0. Then the system is said to be causal. And for system to be stable, the condition is summation k varies from minus infinity to infinity. Mod of h of k, its value should be less than infinity. Similarly, for continuous time signal, h of t must be equal to 0 for t is not equal to 0. For causal system, h of t is equal to 0 for t is less than 0. And similarly, for system to be stable in continuous time domain, the condition is integral minus infinity to infinity h of tau d tau, its value must be less than infinity. Now let me consider first example, that is h of n is equal to phi delta n. H of n is equal to phi delta n. Let me draw the h of n signal. So here h of n signal exists only at n equal to 0, because we know that delta n value is equal to 0 only for n equal to 0. So for n equal to 0, its amplitude is phi. So here we can see that h of n is equal to 0 for n is not equal to 0. So here we can see that h of n value is 0 except n equal to 0. Therefore the system is memoryless. Therefore system is memoryless. Here we can see that h of n value is 0 for n less than 0. Therefore this system is causal. So let this be memoryless. Second one is causal. Here we can see that h of n value is 0 for n less than 0. Therefore system is causal. Now let's check the stability of the system. Here we can see that h of n exists only for n equal to 0. Therefore h of k value is equal to phi. Definitely phi is less than infinity. Therefore system is stable. Let's consider second example. H of n is equal to 1 by 4 power mod n. Here mod n indicates n can take negative values as well as positive values. If I draw h of n signal, it looks like this. Let me draw h of n signal here. Okay, this is h of n. Let n equal to 0, 1, 2, 3, 4 and so on. Let this be minus 1, minus 2, minus 3 and so on. If you take n equal to minus 1, then h of n value will be 1 upon 4 inverse. So that is nothing but 4. So at n equal to minus 1, it is 4. At n equal to 0, it will be 1. So let this be 1. When n is equal to minus 2, it will be 4 power 1 upon 4 power minus 2, that is nothing but 4 power 2, that is 16. and so on. Now if you consider n is equal to positive, that is n is equal to 1, then it will be 1 by 4, that is nothing but 0.25. Let this be 0.25, 0.625 and so on. Now let's check the condition for memoryless. So here we can see that h of n. So now let's check for memoryless. That is, here we can see that h of n is not equal to 0 for n is not equal to 0. Therefore, system is not memoryless. Now let's check for causality. The condition here we can see that h of n value is not equal to 0 for n less than 0. As we see here, for n less than 0, h of n has some values. Therefore, system is non-causal. System is non-causal. Let's check for stability. The condition is summation k is equal to minus infinity to infinity h of k, which is nothing but summation. Here h of n is two-sided sequence, so I can represent it as summation k is equal to minus infinity to minus 1 h of k, that is 1 by 4 power minus k, plus, now consider the summation k value from 0 to infinity, that is k is equal to 0 to infinity. Here the value of k will be positive, that is 1 by 4 power k. So here this can be represented as, so for the first term put minus k is equal to m. In that case I can represent this as summation m is equal to infinity to 1, 1 by 4. So minus k is nothing but m, plus this can be represented as k is equal to 0 to infinity 1 by 4 power k. So now simplifying this, so this term is nothing but 1 by 4 divided by 1 minus 1 by 4, that is finite series formula, plus we have here 1 upon 1 minus 1 by 4. This is nothing but, we'll get 1 by 3 plus 4 by 3. Definitely this is less than infinity. Therefore, system is stable. Consider the third example, that is h of n is equal to 1 over 2 power minus n u of minus n. So here let me draw h of n sequence for understanding purpose. So here when n value is 0, the value is 1. So here n is equal to minus 1, minus 2, minus 3. It is left sided sequence. So for n is equal to minus 1, the value will be 1 upon 2. That is, the value will be 1 by 2. When n is equal to minus 2, it will be 1 upon 2 square, that is 1 by 4. This is 1 by 4 and so on. Say this is h of n, this is n. Now let's check for the conditions. So here we can see that h of n is not equal to 0 for n is not equal to 0. Therefore, system is not memoryless, because for memoryless system h of n should be equal to 0 for n is not equal to 0. Let's check for causality. Here we can see that h of n is not equal to 0 for n less than 0. That is, here for n less than 0 h of n exists some values, therefore h of n is not equal to 0. Therefore system is non-causal. Now check for stability. The condition for stability is summation k is equal to minus infinity to infinity mod of h of k. So here the k varies from minus infinity to 0. H of k is nothing but 1 over 2 power minus k. Simplifying this, that is, put minus k is equal to m. So in that case we can write it as summation k is equal to m to 0 1 by 2 power m, that is nothing but summation k is equal to 0 to m 1 by 2 power m. So this is nothing but 1 upon 1 minus 1 by 2. Simplifying this, we'll get 2, which is less than infinity. Therefore system is stable. Now consider the next system. H of n is equal to 2u of n minus 2u of n minus 1. Let me draw h of n signal. So first let me draw it 2u of n. So 2u of n is nothing but u of n exists only for n greater than or equal to 0. So this is 0, 1, 2, 3 and so on. This is 2u of n. Let's see what is minus 2u of n minus 1. Let me draw minus 2 u of n minus 1. That is, at n equal to 1, this is 0, this is 1. The amplitude is minus 2. So it exists from 1, that is minus 2, minus 2 and so on. So if we add these two signals, we'll get h of n signal. That is, all the signals greater than 0 will be get cancelled, because 2 minus 2 will be 0. Here amplitude is 2, minus 2 will be 0. So h of n will be having only one sample at n equal to 0. At that time the instant magnitude is 2. So here we can observe that, we'll check for memoryless, h of n is equal to 0 for n is not equal to 0, because it exists only for n equal to 0. Therefore system is memoryless. Now consider the causality. Here we can see that h of n value is 0 for n less than 0. H of n is equal to 0 for n less than 0. Therefore system is causal. Let's check the stability. The condition is summation k is equal to minus infinity to infinity mod of h of k, which is, here we are having only one sample, therefore the value will be 2, which is less than infinity. Therefore system is stable. Now consider the next system, that is continuous system, that is h of t is equal to 3 delta of t. So here let me draw h of t signal, that is, it exists only at t equal to 0. T equal to 0 and its value is 0 otherwise, that is, at that time the amplitude is 3. So let's check for memoryless. Here we can see that h of t is equal to 0 for t is not equal to 0, therefore system is memoryless. Let's check causality. Here we can see that h of t is 0 for t less than 0. T less than 0. Therefore, system is causal. And for stability, it exists only at t equal to 0. Therefore, integration minus infinity to infinity h of k d tau is equal to 3, which is, that is, minus infinity to infinity. H of k is nothing but 3 delta of tau d tau, which is nothing but 3, that is less than infinity. Therefore, system is stable. Now consider the last system. H of t is equal to e power minus 4 mod of t. So this mod t indicates t can take the values negative as well as positive. If I draw h of t signal, it looks like this. So if t values are positive, let these are the positive values of t, and this side is negative values of t. At t equal to 0, the amplitude is 1, and as t value increases on positive side, we'll get the shape of the signal like this, and for negative side it will be like this. So now let's check the conditions. So here we can see that h of t is not equal to 0 for t is not equal to 0. Therefore, system is not memoryless. Now let's check causality. Here h of t is not equal to 0 for t less than 0, because here h of t exists for t less than 0. Therefore, this system is non-causal. Now let's check for stability. The condition is minus infinity to infinity mod h of tau d tau is equal to, here we can see that minus infinity to 0, the value of the signal is, when t values are minus, it will be 4 tau d tau, and when t values are positive, it will be 0 to infinity e power minus 4 tau d tau. So simplifying this, e power minus 4 tau, its integration will be e power minus 4 tau divided by 4 by applying the limit, that is minus infinity to 0, plus here we have e power minus 4 tau divided by minus 4, 0 to infinity. So simplifying this, we'll be having 1 by 4 plus 1 by 4, which is equal to 1 by 2, which is less than infinity. Therefore, system is stable. Thank you for watching.